All right, so the note here says on the test you need to be prepared to do a comparison like this with any of the 15 parent functions without your calculator. So just make sure that you're ready for that. Here, I threw the two trickiest at you. So ln of x, remember our ordered pairs for ln of x are, we have an asymptote at x equals 0, and our ordered pairs are 1, 0, 2.71, and between 7 and 8 and 2. But really, if you have those two, I'm happy. So 2.71, and just don't be ridiculous with the growth here. Log of x, in comparison, has two nice points for us as well. It also has an asymptote at x equals 0. And the points 1, 0, and 10, 1. So this one is going to grow slower than ln of x. And that's really the point to this whole exercise. So if functions can't be compared to a specific value, we're going to say D, N, E. Anywhere we have asymptotes or no value, we cannot compare. So for this problem, at f of 0 and g of 0, again, those are your x values. We have asymptotes, so we cannot compare those. F of 1 and g of 1, so f of 1 is 0, and g of 1 is 0. So at x equals 1, f of x and g of x are equal. And now this is about when our numbers are really big and when our numbers are small. F of 100 and g of 100, you could look at a calculator table if you were allowed a calculator. But here, which one is growing faster? And the one that's growing faster is ln of x, right? Its y values are getting bigger faster. So at 100, ln of x is going to be bigger than log of x. And we don't have values. We can't take the log of a negative, so part D here does not exist. Which is greater as x approaches infinity? As x gets really, really big, our y values are bigger for ln of x. So f of x has greater outputs. Okay, let's look at another. So we have 1 over x squared and 1 over 1 plus x squared that we're going to compare now. So some students come up with like little ways to remember these. 1 over x squared is our volcano function. I guess maybe I should have used red, but I used blue here. We have asymptotes at x equals 0 and at y equals 0. And our function is trying to approach 0 as our numbers get really big and then small. Okay, 1 over 1 plus x squared is our speed bump. And our speed bump looks like this. At 1, it's 1/2. And then it... So at 0, which is greater? Well, you can't really compare an asymptote and a value. So what I would do here is something like this. This guy is an asymptote, and g of 0 is 1. So this does not exist. We can't evaluate which one's greater. We can't compare nothing to something. At f of 1 and g of 1, we can. F of 1 is 1, and g of 1 is 1/2. So f of 1 is greater. All right, what about at 100? Well, at 100, this is where our numbers are really, really big. So which one of these is which one of these is growing slower is your question. So sometimes it's easier to just look at how your equation is working. So let's plug in some numbers for 100. So here I'm going to kind of compare it. So I have 1 over 100 squared, and I'm comparing that to 1 over 1 plus 100 squared. And it's easy to see that your denominator for g of x is going to be smaller. And that means, it's going to be bigger. So this fraction is smaller fraction. So I'm going to say that again because that sounded kind of funny to me when I said it. So our denominator of 1 plus 100 squared is bigger than 100 squared. And so that fraction is smaller. That fraction is smaller. So f of 100 is greater than g of 100 by just a tiny little bit. All right, let's talk about what's happening at negative 100. When we square negative 100, we're going to get the same fraction that we did when we squared 100. So we're going to square the negative and square the 100. So our answer is going to be the same here. And lastly, which is greater as x goes to positive infinity and negative infinity? F of x is greater, but just by a tiny bit for both. Those fractions are just going to be a tiny bit bigger. And this one is a good one. I know you're not allowed to use a calculator on the test, but it's a nice one to look at on the calculator with fractions because you'll see those denominators differ, they're off by 1. And that's a really nice kind of little visual for you to have on that.